Number 5, page 5. Sequences. A sequence is a list of numbers, but it's also at the same time a function. How will a sequence look like? A finite sequence will look like this. A1, the first term, comma, A2, the second term, A sub 3, dot, 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 till AN, till the last one. Why is it finite? It's because it ends somewhere. There is also what we call infinite sequence that goes on forever. A1, A2, A3, dot, 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 AN, the general term, and dot, dot, dot. It's infinite. It never stops. We're not going to work on infinite sequences, but we're going to work on finite sequences. And I also said that sequences are functions. A sequence is a function. The input is 1, 2, 3, dot, dot, dot. And what is the output? For the first one, the first term. For I equals 2, the second term. For I equals 3, the third term. Dot, dot, dot. For n, of course, I'll have A sub n. And full stop. We are talking about the finite. So the input is 1. When you say 1, I'm thinking of the first term. When you say 5, I'm thinking of the 5th term, the 5th term. When you say 10, I'm thinking of the 10th term, and so on and so forth. A sequence can be given to us in 2 different ways. So sequences, I don't know if this is a good color. Can be given in 2 ways. Here's one, the first one. Given A sub n, which is the general term. And I want to stop and just look at one example. Number on page 752. Let's look at number 9 because I think I did on 752. I think I did number 10 with them. So A sub n to n divided by n plus 4. They're asking us to find the first 4 terms. So they're asking us to find A1, A sub 1, and then A2, and then A3, and then A4. How do I determine this? Well, this is the general term, this one. How do I determine this? Plugging in 1 for n. How do I determine this? Plugging in 2 for n. Again, here, plugging in 3, and so on and so forth. All I have to do is just plug in 1, and then plug in 2, and then plug in 3, and perform the calculations. So when n is 1, I have 2 times 1 divided by 5. When n is 2, I have 4 divided by 6, which is 2/3. When n is 3, I have 6 divided by 7. And when n is 4, I have 8 divided by 8, which is 1. So given the general term, no difficulty whatsoever. And if you say, find the term 100, no problem. I can find term 100. So it's 200 divided by 204, and I'll simplify by 2, and I get 100 over 102, and I can simplify again by 2, and I get 50 over 51. You can ask me any term. because I'm given the general term, I can find any term. Just give me n, and I'll find it for you.
I have a question. Why is the denominator 204 if 100 is the input? Oh, okay, my bad. No, I thought I was misunderstanding.
I'm sorry. I did plug in 100. Yes, of course. I'm sorry. Thank you. Thank you. So 100 over 52. Thank you. And then 50 over 26. Thank you. My apologies. No, I wasn't trying to make sure that somebody's paying attention. No, it was just not paying attention. Okay. Any questions? Should we look at another one? Let's look at another one. Number 8, same page, 752. We have a sub n, the general term, -1 raised to power n plus 1, and then everything multiplied by n plus 4. Same question, they want us to determine a1, a2, a3, a4. When we plug in 1 plus 1 is 2, but -1 to the second power will be positive, so I don't have to write anything. And then 1 plus 4 is 5. When I plug in 2 plus 1 is 3, but that makes this negative, so it's going to be negative. I plug in 2 plus 4 is 6. I plug in 3 plus 1 is 4, -1 to the fourth power will be positive, and 3 plus 4 is 7. I plug in 4 plus 1 is 5, -1 to the fifth will be negative, and 4 plus 4 is 8. So as you see, the input is 1, 2, 3, 4. The output is 5 for 1. In other words, something like this, and this is how we create a function. For 1, we get 5. For 2, we get -6. For 3, we get 7, and so on and so forth. And this is a function. 1 being the index, 2, 3, the index, and each entry or each output is an element of the sequence. These are the elements of the sequence, and this is the input, the index. Okay, now this was the first method, right? The sequences can be given to us in 2 ways. Here's one. I'm given the general term. I can determine anything you want. And here's the second possibility. The second possibility, when we are given what it's called recursion formula. We're not given the general term. We're given something that resembles the general term, but it depends on the previous terms. So I'm looking at an example. Let's look at 13 on 752. Where we are given that a1 is 7, so the first term of the sequence is given to us. And then a sub n equals a sub n minus 1 plus 5, and this is happening from n being 2 or more, not 1. So this is happening for n greater than or equal to 2 because a1 is already given to us. It's the same question. They want us the first 4 terms. Okay, I do have the first term. So I only have to determine a2, a3, and a4. A sub 2, a sub 3, a sub 4. How do I do this? Well, first of all, I need to understand this formula, because I'm not given a sub n directly. What does this formula say? If you're looking for a sub 7, the 7th term of a sequence, it depends on the previous one. Because if n is 7, then this is 6. So a sub 7 equals a sub 6 plus 5. So I cannot determine a sub 7 if I don't have a sub 6. I cannot determine a sub 10 if I don't have a sub 9. So every term depends on the previous one. How? The previous one plus 5. So then how do I get a sub 2? It's the previous term plus 5. How do I get a sub 3? It's the previous term plus 5. And finally, how do I get a sub 4, or the fourth term of the sequence?
17 plus 5.
That's it. 17 plus 5, 22. That's why this condition is very important, because I can plug in 1. If I plug in 1, then a sub 1 will be a sub 0. There is no a sub 0. So that's why this formula works for n greater than or equal to 2, because they already gave us a sub 1, the first term of the sequence. Okay, let's look at another. Let's say 17, same page. So we have a1 is given to us, and a sub n is 2a sub n minus 1 plus 3. And of course, this formula must be for greater than or equal to 2. Same question, they just want us to determine the first 4 terms. They want us a1. Thank you very much, I have it. They want us a2, a sub 3, and a sub 4. I look at the formula to understand the pattern. The pattern says any term of the sequence will be obtained by multiplying the previous term of the sequence by 2, and the result adds 3. So can anyone give us a sub 2?
11.
Yes, because it will be 2 times 4, 2 times the previous term, and plus 3, which will be indeed 11. What about a sub 3? Notice that if you ask me to find a 100, I'll say sorry. I can't. Why? Why on the previous example with my mistake including, I was able to find with some difficulties, and I had to erase because I made an error, but I was able to find a sub 100 or the 100th term, but here I can't.
With these ones, don't you have to find all of the
Previous 99 terms. Then I will get tired. At some point in time, I'll get very tired. You can give me this task and I'll probably finish it by Monday. Okay, so a sub 3 will be?
25.
Yes, 2 times 11, which is 22, and plus 3, which is 25. And the last one will be 2 times the previous one, plus 3.
50. 50.
That's it. That's it. One last type of problem, and there is nothing else from this course. We're finished. Is to find the summation notation. So we are given, let's say 44. 1 to the 4th, 2 to the 4th, 3 to the 4th, plus dot, 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 exactly 3 dots, 12 to the 4th. And they want us to come up with the condensed sigma notation. Okay, so I will always try and see if the index, any index you'd like to use, this time let's use J. So I'm looking at the fact that all these numbers have power 4. So the general term must have power 4. There is no discussion there. Okay, so if J equals 1, I get 1 to the 4th. If J equals 2, I get 2 to the 4th. And if J equals 12, I get 12 to the 4th. So where do I stop? from j equals 1. And what is the upper limit?
12.
Very good. And now the question is, what should I put in here so that when I plug in 1, I get 1 to the 4th plus, the sigma says plus, because there is another symbol. There is this symbol as well, but that means the product. We're not working on the product. But this says sigma, right? It's a sigma notation, which means plus. When j equals 2, I have 2 to the 4th, and then plus. When j equals 3, I have 3 to the 4th, dot, dot, dot. When I get to the last one, and I plug in 12, I get 12 to the 4th. So what should I have here that works?
J.
Very good. Okay, so let's look at 50. 1 over 3 plus 2 over 4 plus 3 over 5 plus 3 dots plus 16 over 16 plus 2. Same thing. They want us to condense all this. Let's use K this time. Doesn't matter. You can use anything you want. You can use B and T and V. It's not important. Okay. So first I'm going to look at the numerator. And I'm going to say, okay, so maybe when K is 1, I get that. When K is 2, I get that. When K is 3, I get that. And dot, dot, dot. When K is 16, I get this. So what should be the lower limit for the index, and what should be the upper limit for the index? And we'll check and see and make sure at the end that everything is correct.
1 and 16.
1 and 16. Very good. Obviously, all terms have a fraction. Well, the general term has to have a fraction. Again, let's finish up with the numerator. What should I have here so that when K is 1, I get 1. When K is 2, I get 2. When K is 3, I get 3. When K is 16, I get 16.
Okay.
Good. And now let's look at the denominator. Now when K is 1, I want to get 3. When K is 2, I want to get 4. When K is 3, when K is 2, I want to get 4. When K is 3, I want to get 15. When K is 16, I want to get 16 plus 2. So what should the expression be here in the denominator so that I get those 3, 4, 5, 16 plus 2? What do you think? Anyone? So when K is 1, I get 3. When K is 2, I get 4. When K is 3, I get 5. And then at the end, I get 16 plus 2.
So it'd be like K plus 2.
K plus 2. Let's go back and check one more time, make sure. When K is 1, yes, the denominator is 3, the numerator is 1. When K is 2, yes, the denominator is 4, the numerator is 2. When K is 3, yes, the denominator is 5, the numerator is 3. Finally, I get to 16. 16 and 16 plus 2, correct. Any questions on this? Okay, let's look at a word problem. Number 80 on page 754. And after this, I'll do whatever you want me to do. Work on any problem, review anything. This is it. You buy a new car for $24,000 And at the end of n years, the value of the car is given by this sequence. 24,000, 3 over 4 to the nth power. And of course, n is 1, 2, 3, dot, dot, dot. Find A5 and write a sentence explaining what this value represents. Okay? Well, this is not a recursive formula, right? This is just the general term. I should have no difficulties finding the value of the car 5 years later after we purchase it today. What will that be? $24,000, and in parentheses,
3 or 4.
everything to,
It's to 5.
that's it. So let's see what the value of the car will be in 5 years. That's a simple application of sequences. So 24,000, and in parentheses, I'm going to just put 0.75 because it's easier for me. And then I put caret to the 5th power, and I get, oops, not good, 5,695.31. Pretty bad. Pretty bad. In